In this video we're going to look at transformations, specifically reflections. When we have a shape and we transform it, its shape can change size, orientation or position. There are 4 transformations: reflections, rotations, translations and enlargements. The position a shape is transformed to is called the image, and the shape it's mapped to is called the object. One other thing as well that we have is if we have a triangle and this was the object, we might label the vertices A, B and C, and if we did some form of transformation, the corresponding vertices would be A dash, B dash and C dash. If we were to do a subsequent transformation, then what we would have would be A double dash, B double dash and C double dash, and so on. So when a shape is reflected, it stays the same shape and size. Its position is changed and the orientation is reversed. A reflection requires a line of reflection or a mirror line. And for this we should be familiar as well with the lines y equals A, which are all horizontal lines passing through the y-axis at A, or x equals B, which are vertical lines crossing the y-axis or the x-axis at B, and also the form of y equals plus or minus x. So to reflect the shape, we draw the mirror line. We count the perpendicular distance of a corner of the shape to the mirror line. So for this triangle, we would count the distance from each vertex or each corner to the mirror line, and we go in a distance that's the direction that's perpendicular to the mirror line, and then we repeat the same on the other side. And we do this with all corners and then we join them up. So example 26, reflect the shape S in the x and the y-axis. Label the images S dash and S double dash. So if we go first of all in the x-axis, what we can do is we can see that this point is, so we're going with the x-axis, and the perpendicular direction to the x-axis is the vertical direction. So if we start from this point, we move 3 squares down, and the image is going to be 3 squares on the other side. Then we'll go to the next point, and we can see it's 4 squares to the mirror line, so then the image is going to be 4 squares on the other side. And then with the last point, it's 5 squares to the mirror line, so that's going to be reflected 5 squares on the other side to here. And then we join the points up and we'll label it S dash. Then we're going to do the same with the y-axis. So we're going to count the squares perpendicular to the y-axis, which is this horizontal direction. And we can see it's 1 square to the mirror line, so the image is going to be 1 square on the other side. We go to the next point and we can see that's 2 squares to the mirror line, so we'll go 2 on the other side. And then the last point is 5 squares to the mirror line, so we'll go 5 on the other side. And then we join those points up and we've got the shape S double dash. Example 27, reflect the shape T in the line x equals 1 and label it T1. So x equals 1 is a vertical line passing through the x-axis at 1. And what we need to do then is count the squares from each vertex to the mirror line. So we can see that's 2. So the image is going to be 2 squares on the other side. Then we'll go to the next point and we can see that's 4 squares to the mirror line. So we're going to go 4 squares to the other side and mark that point. And then the last one is 3 squares to the mirror line. So we'll go 3 on the other side. And then we join the points up and we'll label it T1. Part B, we're going to reflect T in line y equals x and label it T2. So y equal x is the diagonal line and crosses through all the points from 0, 0 up to 6, 6, and so on. So now what we need to do is count squares in a direction that's perpendicular to the mirror line, which is going to be diagonally. So we'll count from each vertex diagonally. So from here to the mirror line, we go diagonally across 2 squares. So then we'll replicate that on the other side, and we'll end up at 2 minus 2. We go to the next point, and we'll go diagonally 2, 3, 4. So we keep going and do 4 on the other side. 1, 2, 3, 4. We end up at 0.5 minus 3. And then the last point, we go diagonally 1, 2, 3 and a half. So we'll do the same on the other side. So a half, 1.5, 2.5, 3.5. So the last point is at 6 minus 1. And we can join those up. And we've got the shape T2. The third one is the line y equals minus x. And that's the diagonal line going in the other direction. And that'll pass through minus 6, 6. And all the way down through 0, 0 to 6 minus 6. So we need to count the squares diagonally then to the mirror line. So we'll be going in this direction. So if we start off with this point, we go 1 square diagonally. So we'll go 1 square on the other side. So that's at the point minus 5, 3. Then we'll go to the next point and we go 1, 2.5. So we'll go a half, 1.5, 2.5. So to minus 6, 1. And then the last one we can see is on the mirror line, so we'll not be going any distance from it. So if we join those 3 points up, then we've got our shape T3. And then lastly, we want to reflect in the line y equals 4. So y equals 4 is a horizontal line which passes the axes at 4. So we're going to count squares vertically. So from our top point to the mirror line is 2. So we'll reflect that down 2 squares. The bottom point is 2 squares beneath the mirror line, so we'll reflect that 2 squares up above it. And then the last point is 1 square above it, so we'll reflect that 1 square beneath it. And then if we join those points up, then we've got shape T4. To fully describe a reflection, we need to give these 2 pieces of information. So we need to tell what type of transformation it is. So in this case, it's going to be a reflection. And we need to know the equation of the line of reflection or the mirror line. So the information we'd be needing to give would be, we've got a reflection in the line y equals 2, or the line y equals x, or the line y equals 0. Now remember, in this you could say the x-axis or the y-axis, but the equation of the x-axis is y equals 0, and the equation of the y-axis is x equals 0. Example 28, describe fully the transformation which maps U onto T. So what we can see clearly is that this is a reflection. So what we need to know is the mirror line. What we can do is we bisect, so we cut in half the distances. So we can see from the top point to the middle point, at the other point, the corresponding point, the middle of that is this point. And if we correspond these 2 corner points, they're the ones that correspond to each other. The middle of that is 0.41. And that's the same point for the third one. So if we join a line that connects these points, we've got this vertical line which passes the x-axis at 4. So that means this is a reflection in the line x equals 4. Had this been a diagonal reflection, really the only ones that we'd be asked to work out, although we should be able to figure out any of them, would be the line that is diagonal through the points 1, 1, 2, 2, 3, 3, 4, 4, and so on. And that would be the line y equals x. Or if it was going diagonally in the other direction, through the points 1, minus 1, 2, minus 2, minus 4, 4, and so on. And that would be through the line y equals minus x. We wouldn't really see very often that we'd have to do the line y equals x plus 1 or y equals x plus 2, or even y equals 2x. So the diagonal mirror line should be fairly straightforward.